Welcome back to JK Math Academy, and in this session we will be seeing one of the most important concepts of algebra, the number line. And then we will follow up with absolute values, and as usual we will be also looking at multiple examples and exercises for you to follow up. As suggested, we will be seeing one of the important topic, number line, in this chapter, and absolute values. Let us see what they are. This is how a number line will look like. This one we will be seeing all across algebra. So it's a very important concept to understand what this is and how to use it. And once we are comfortable with this as to how to use it, then we are good to go in algebra for most of the calculations and evaluations. Just imagine a line like this, a straight line with arrows on both sides, which means it keeps going infinitely to the on both sides. Then there is a center point which is 0. This is what is the center point of this line, and we have to 0. This is an imaginary line. We have to keep this in mind. Then we have positive numbers here, 1, 2, 3, 4, and so on till infinity. And we have -1, -2, -3, -4, and so on till infinity. So these are all the negative numbers on this side. Anything to the left of the 0 is negative numbers, and anything to the right of the 0 is positive numbers. It always goes from 0, 1, 2, 3, 4. That means the numbers are increasing. When we are going this side, the numbers are decreasing. When you say -1, it is one value away from 0. -2 is two values away from 0 on the negative front, actually. So when you say whether -2 is small or -3 is small, it is always whatever is there on the left of the two numbers which is small, which is similar in the positive numbers also. For example, you see 2 is less than 3, 3 is less than 4. Same way, -3 is less than -2, and -2 is less than -1. So that is how you have to understand this. Anytime you go to the left on this number line, anywhere, whether it is a positive or negative, that is a smaller number compared to the one on the right. -4 is smaller or -1 is smaller. -4 is smaller. 1 is smaller or 4 is smaller. 1 is smaller. So that's how you have to look at it. -1 is bigger or -3 is bigger. -1 is always bigger. Always remember the left one is less and the right number is positive in this number line. 2 is greater than 1. 4 is greater than 2. 4 is greater than 1. So this is how you have to look at this. 0 is the central point. So 0 is less than 1. But 0 is greater than -1. This is a very important concept when you are going to do beginning days addition, subtraction. To the end of algebra, you will be seeing this number line, and you will be learning a lot about this number line actually. And then let me see what I have written here. The negative numbers are a mirror image. So basically these are called mirror images, but I don't think you need to worry too much about it. But there is in mathematics, you will see that there are a lot of terminologies like this. But at a certain stage, I have seen that this comes into use, but that's a very far off state. We will see that somewhere in algebra 2, you will see this negative value comes into picture. You will see that when you say opposite, what is an opposite? But for now, you should know which is smaller and which is bigger in this number line as you traverse this line. So that is how you have to see. For example, 4 minus 2 is 2, right? So what is 2 minus 4? So that is what we are going to see with this number line. Those things are what are very important to see now. We know 3 minus 2 is 1. And what is -1 minus 2? We don't know at this stage. So we will learn all that. Minus a means opposite of the number a. As of now, remember that. You don't need to remember also. Just know that it is called as a opposite of, basically it's a mirror image, right? If you fold this at the 0, so it will become 1 and -1, 2 and -2. So that is why it is called as a mirror image, and nothing more than that. But understand the number line, which is very important. The positive numbers, the negative numbers, how do you see which is small, which is big, and where does 0 stand in this picture? 0 is the dividing point for both positive and negative numbers. This is what we need to understand with number line. Let us see one way of viewing the number line using what is called as an absolute value. Take the point 0 here. 0 to 1 is 1 point, we will remember, and 0 to minus 1 is also 1 point, and both of them are the same distance. If you really see from here to here, it is the same distance. 0 to 1 and 0 to minus 1 is same. 0 to 3 and 0 to negative 3 are the same distance. What I'm trying to bring out here is, in later on sessions, specifically when you are doing business applications, we don't call them business applications in classes in schools and colleges. We will call them word problems. So many times you will see questions which are related to these absolute values. Direction, distance mainly. When you say two friends are traveling, one is traveling this side and one is traveling this side, we will be seeing questions like this where we will be forced to use these concepts of the number line, where how much distance he has traveled. There's nothing like negativity in that concept here. So that is where absolute values come into the picture. The distance between 0 and 1 is 1 mile, for example. 0 to minus 1 is also 1 mile. 0 to 4 is 1 mile, and 0 to negative 4 is also 4 miles. So we should know that the distance between, whether it is positive or negative, the distance or the distance between these 2 points don't change actually. Both are 4 miles. 3 miles to here from 0, 3 miles to here from 0. But if a student travels up till here on one side and the second student only travels up till here, now we can see at what speed they had traveled and why they had traveled less if they started at the same time, and so on. We'll be seeing these kind of examples as we go forward. But for now, in this session, what we are trying to understand is the distance between these two. When we call them 1 mile and 1 mile, basically here we are saying this is an absolute value. For example, 0 to negative 1, the absolute value is 1. 0 to negative 2, the absolute value is 2. 0 to 1, the absolute value is 1. 0 to 3, the absolute value is 3. So whichever way you go, 0 to 100, the absolute value is 100. 0 to negative 100 this side will also be 100. Absolute values are always greater than 0. You have to remember that. Whether it is the negative side or the positive side, an absolute value of a number is always greater than 0. For example, an absolute value is represented like this. Absolute value of 3 will be this line 3 and then a line, and absolute value of that number is always greater than 0. Remember that. That itself will give you a clear picture of what an absolute value is. An absolute value can never be negative. So for example, let us see this. Minus 4 is 4 units away from 0. What is saying is minus 4 here. Minus 4 is 4 units away from 0. Minus 4 is, so how do you represent minus 4 as an absolute value? Like this. So negative 4, absolute value of negative 4 is 4. 4 is 4 units away from 0. That is true, we know. 4 here is 4 units away from 0. 1, 2, 3, 4. So how do you represent the absolute value of this 4? It is like this. But the absolute value of this is also 4 because it is 4 units. Negative 4, absolute value of negative 4 is also 4 units, and absolute value of 4 is also 4 units. So that's what we need to understand. We'll see some examples, but understanding what is an absolute value on a number line is also the next important point that we are covering in this session. I'm keeping the diagram of the number line just so that we have it in front of us. But as we go by, you will see that this will be in our mind and we'll be working on these examples. We won't look at the number line all the time actually, and I'll show here itself why that is not required. And let us start with some examples. Here is the first example. See the first line in this one. Absolute value of negative 3 is greater than, less than, or equal to negative of absolute value of negative 3. See that problem. How do you read this is absolute value of negative 3 is greater than, less than, or equal to negative of absolute value of negative 3. It's a question. Basically, they are trying to ask whether it is small, the left number is smaller, greater than, or equal to. So first what we do is convert the absolute values into regular numbers. So let us see what we do. Here, first when you convert this negative 3, absolute value of negative 3, it becomes 3 actually. We know that. We saw in the last slide. Now, this negative doesn't go anywhere. This negative doesn't go anywhere, so it stays here, negative 3. So, negative value of absolute value of negative 3 is negative 3 still. Here we have absolute value of negative 3, which becomes positive 3. So now this is negative 3 and this is positive 3. So 3 is definitely greater than positive 3. What did we say? Anything to the right of this number line is a bigger one. So 3 is definitely bigger than negative 3. That's what we are trying to say here. 3 is greater than negative 3. Are you able to say how the number line helps here? 3 is greater than negative 3. We know 3 is greater than negative 2, 3 is greater than 0. Sorry, 3 is greater than 2 and 3 is greater than 0. But we don't know whether till now, before algebra, we don't know whether 3 is greater than negative 1. But we now know because on the number line it is to the right of this negative 1, it is always bigger. So that is what we are trying to do here. 3 is greater than negative 3. Let us see another example. 4, which has nothing to do with any absolutes here. And how do you compare it with? Negative of absolute value of negative 4. So 4 remains the same in this second step, and negative times negative 4, similar to negative times negative 3 of absolute value, this becomes negative 4. So 4 is greater than or equal to or less than negative 4. We know 4 is on the right of negative 4 on the number line, and so it is bigger. That is what we are trying to say here. We will not keep seeing the number line again and again, but we should keep that in mind. In our mind, that is what should be visible. 4 is always greater than a negative number. Now let us see one more example. Absolute value of negative 5 and negative of absolute value of negative 5. Absolute value of negative 5 becomes 5. We have seen so many times now. Absolute value of negative 3 becomes 3 and absolute value of negative 5 becomes 5. Absolute value of negative 5 is 5, whereas there is a negative here, so it becomes negative 5. Is 5 greater than negative 5? Yes. So all of these are positive numbers, in the right side it is negative numbers. So those are all greater than. Now let us see a slightly different example. There is a negative 9, no absolutes or anything there. Then there is a negative of an absolute value of negative 9. Minus 9 remains the same. It doesn't do anything. It doesn't change at all. It's a constant. Understand? This is a constant now. So here there is some conversion we have to do. So this negative absolute value of negative 9 becomes 9, but this negative stays here, and so it becomes negative 9. Is negative 9 equal to, greater than, or less than negative 9? Obviously, we all know 1 is equal to 1. Negative 3 is equal to negative 3. It cannot be different. And did you see here? We don't have 9 on this number line. How did we do that? That is what I meant by saying this need not be in front of us as a picture. In the beginning days, you can have it and use it to understand, because we will be doing a lot of examples for addition and subtraction. Then let us see even bigger numbers. So here you can't have a number line and say I'll go up till 108 actually. Or I'll draw a line up to 108 and keep counting. No, that is not the way. Number line is a vision in our mind which we will use. So let us see two more examples. See this one. What is this? Negative of negative 16. I said off. Off in algebra or mathematics is always meaning multiplication. And we also saw in a previous session where if there is a number in front of a parenthesis, that means it is being multiplied by what is there inside the parenthesis. So here when you see only negative, that means it is negative 1. Negative 1 times negative 16. That is what this means. Here it is absolute value of negative 16. Nothing changes here as far as absolute values are concerned. There is no absolute value here. We'll come to that. Here, absolute value of negative 16 becomes 16. We have seen enough examples now and we know that. Here we are trying to multiply minus 1 times minus 16. We have not seen much of how to multiply these things. But when you multiply a negative with a negative, it becomes a positive. We will see a lot of examples. But for now, don't worry. Here I am only trying to show examples of how only a absolute value we need to worry about converting inside the absolute value. Here we will just multiply it. And we will be seeing multiplication of algebraic notations. So this becomes 16 and this is also 16. So 16 times 16 is equal to 16. That's what we are saying. Now same way, this is negative 1 times negative 108 and absolute value of negative 108. Absolute value of negative 108 will become 108 and negative 1 times positive 108. See this, there is a difference between negative 1 times negative 16 and negative 1 times positive 108. So negative 1 times negative was 16 here, negative 1 times positive is negative here, negative 108. We will see these. But for now, understand that we are trying to do some absolute value and non-absolute value equations or expressions. So negative 108, is it less than 108? Obviously, because if you draw a line here up till 108 and draw a line here up till negative 108, 108 is on the right of negative 108. So that says that negative 108 is less than 108. These are exercises for you, but I'll still give a little walkthrough of what I am doing. I have given the answers also, but don't look at the answers and try to do them. See, absolute value of negative 2 becomes 2. Absolute value of negative 2 becomes negative 2. 1 stays the same, it's a constant. Negative times absolute value of 1 becomes negative 1. Like negative value of absolute value of negative 2 becomes negative 2. Absolute value of negative 6 becomes 6. Absolute value of negative 6 becomes 6, but there is a negative here in front of the absolute value symbol, so it becomes negative 6. This is a constant. Negative 11 stays negative 11. Here, negative 11 becomes positive 11 because of the absolute value symbols, and then there is a negative here, so this becomes negative 11. So both of them are going to be negative 11. You will know the answer then. Here again we are talking about multiplying. These two are multiplying, not absolute values. These are absolute values. Always remember, when you multiply a negative number with a negative number, it will become positive. We'll see those things a little later. And if you multiply a negative number with a positive number, it will become a negative number. Remember that and try to do these examples. That is how you will learn what are absolute values and how do we do the conversions and examples. Remember order of operations and PEMDAS. If you need a revision of order of operations and PEMDAS, please refer to the link on this video and it will show you how to do those in detail. Here I am not going to go into the details of it. Here only we are going to see how they interact with absolute values. So absolute value symbols also have a order of operation. And in the PEMDAS concept, absolute values get the highest order of operation. When we use the order of operations, first we simplify inside the absolute value bars. That is more important. Start with the absolute values. After that only even brackets come into the picture. Within the absolute value, whatever is there, that is what we have to simplify first. The best way to see this is again with an example. So let us see an example here. See this. 24 minus absolute value of 19 minus 3 times 6 minus 2 is what is the expression we have to evaluate. So what we should do is, First, evaluate this expression. 24 remains as it is till the end, you see. Till you bring this to a single number, 24 remains the same. So first we have to evaluate this expression. And within this, what is the smallest one that we have to do? First thing which we have to do, parenthesis. Remember PEMDAS, parenthesis. So parenthesis 6 minus 2 is what we will first do inside the parenthesis. So that becomes 4. That's what we are doing in the first step. 19 minus 3 remains the same, 24 remains the same, everything else remains the same, even the absolute value still remains because there is more to do. Next, what we do in this 24 minus absolute value of 19 minus 3 times 4, still inside the absolute value there is a multiplication involved. So we have to do that. Remember this order of operations is very important. 3 times 4 is 12. That is what we did here, and 19 remains the same and 24 remains the same, and the absolute values still remain. Then the next step, we convert this 19 minus 12, which is 7, and the absolute value still remains. So 19 minus 12 is absolute value of 7. So now absolute value of 7 becomes 7. We know that. We saw that in the previous part of the session. And now we are ready to do 24 minus 7, which is 17. So that's how we do the absolute values. The first step is to look for absolute value symbols and try to convert or evaluate them first as using the PEMDAS. As per the PEMDAS concept, you have to evaluate within the absolute values. Now, with that example, try to do these two. I'll give you a small introduction to one of them. I've given the answers also, but don't look at them, as I always keep saying. The reason I give the answers is, at least after I do, I want to know whether I did it right or wrong. So that is very critical actually. We need feedback. We don't want to be in the dark and keep Googling and all that stuff. So here, this is the first part we will do in this expression. 19 minus absolute value of 11 minus 4 times 3 minus 1. The next step is there is a multiplication within this. So within the multiplication, there is a 3 minus 1. That is what we will first do. So that becomes 4, and 4 times, 3 minus 1 is 2, and 4 times 2 is 8. Now there is a 11 here, and then there is an 8 here. So absolute value of 11 minus 8. That becomes absolute value of 3. And 19 minus 3 becomes 16. That's what I given here, but do not see the answer. This is a stage where you have to learn thoroughly, do enough of practice, and you should be good to go. And I'm sure you are working on something in your classes and schools. Try to do all the examples, as many examples as possible, all the homeworks. That is how we learn mathematics. And in these kind of sessions, it's very important. We'll be using all of these very, very in depth as we go by. So be clear on certain concepts and try to register in your mind. Absolute values and mainly the number line is a very critical concept in algebra. Two things we learnt in this session. One of them is a very important concept, as I have been stressing all along, the number line. Please try to master the number line and register in your mind as to what are the positive and negative part of the number line and where it starts and how it goes into infinity and so on. That is a very critical concept. We will be going on over that almost in all the sessions as we go in algebra actually. And then we saw absolute values. We'll be seeing the value of or the power of absolute values as we move forward with word problems, as I was saying. And as always, if you like what I am teaching, please like, share and subscribe, and good luck in your path of algebra.